A flood of toxic sludge. A tragic ecological disaster. The chemistry behind the catastrophe, and how it happened. What chemicals, and specifically ionic compounds, were present in the sludge? What happened to the residents of the local villages? On October 4, 2010, in the country of Hungary, the 10-story high corner of a caustic waste reservoir collapsed, holding 14.5 million tons of chemical waste from an aluminum oxide production plant. A massive sea of caustic red sludge with a volume of over 1 million cubic meters was released on local towns and countrysides, with waves of sludge reaching heights of 3 to 7 feet in height. The sludge's volume and strength was powerful enough to move cars and destroy bridges. What was in the sludge that made it so harmful to living things? The red sludge is a mixture of byproducts from the Bayer process in the production of aluminum oxide, also known as alumina, from bauxite ore. What is the Bayer process? Aluminum is the second most produced metal in the world, second only to iron, and we use it in so many industries. The predominant source of aluminum is bauxite, a sedimentary rock which naturally contains 30 to 60% aluminum. In order to purify the aluminum out of bauxite, a famous Austrian chemist, Carl Joseph Bayer, developed a method in 1888 that adds heat and sodium hydroxide to bauxite in a high-pressure vessel. The byproduct of this process is a red mud with a number of elements and compounds. Deterioration of the waste reservoir walls was partly to blame by the company and regulators that allowed their condition to worsen through neglect. But the summer leading up to the disaster was also an unusually wet and rainy summer, and these two factors together led to a catastrophic combination. What exactly was the chemical composition of the red sludge? The majority of the compounds were ionic compounds, with the exception of silicon dioxide, which is a covalent compound, SiO2. 6 to 10% of the sludge was calcium oxide. The formula for ionic compounds like calcium oxide is based off the charges. A calcium ion has a charge of +2, while oxide has a charge of -2. In order to make a neutral compound, you need just one of each. Calcium oxide's formula is CaO. 4 to 5% of the sludge was titanium oxide. Titanium has a few common oxidation states, but in this instance it has a charge of +4. Looking at the charges of each ion present, we need 1 titanium for every 2 oxygens to make it balanced, so titanium oxide is TiO2. Even though aluminum oxide is the desired product in the Bayer process, it still ends up in the sludge. An aluminum ion has a +3 charge, oxide again -2. The correct ratio for this one is a little trickier. 2 oxygen for every 1 aluminum isn't quite right. And 2 and 2 isn't quite right either. Looks like we have a little too much positive charge. Let's try 2 aluminum and 3 oxygen. There, that looks balanced. About 10 to 15% of the sludge was aluminum oxide, Al2O3. 40 to 45% of the sludge was ferric oxide. This is what gives the sludge its distinctive red color. A ferric iron ion has a charge of +3, while oxide has a charge of -2. This should look familiar. It looks like the last one. We need 2 iron to give a +6 charge to balance with 3 oxygen that gives a -6 charge. So overall, it will be neutral. Iron 3 oxide is Fe2O3. Lastly, many of the ionic compounds so far might be irritating to the skin, but the ionic compound really responsible for the chemical burns that local residents and emergency workers received was from sodium oxide. Sodium oxide is highly alkaline with a high pH and is caustic, burning tissues when exposed to it. Sodium ions have a +1 charge, and oxide again is -2. So let's see. We'll need 1 oxygen and 2 sodium. There, that looks neutral. Sodium oxide is Na2O. Notice how most of the ionic compounds listed have a metal. Calcium, titanium, aluminum, iron, and sodium are all metals. Silicon dioxide does not have a metal. That's a good rule of thumb for chemistry. Most ionic compounds have a metal and non-metal element in the compound. Now that we know the chemical makeup of Hungary's biggest ecological disaster, what kind of devastation did the sludge cause? The flood of sludge covered 16 square miles of land, causing 700 people to lose their homes. Over 400 people were burned from the liquid, 120 of which had severe injuries requiring hospitalization. 10 people died in the initial deluge. The countryside still bears the scars of the disaster. Farmland that became infertile, ponds devoid of life, dust on the ground that irritates lungs and have lasting health effects on those who chose to return. The Ajka Alumina Plant accident is a haunting reminder of what can happen if we don't consider our moral obligation to keep our communities and world safe as we pursue the cultivation of our world for our needs and wants.